Құрметті көрермендер, біз басқа Каспий деңгейінен 25 минут төмен ғылыми подкастымызды бастаймыз. Our guest today, Vincent Fan. Yeah. He is a lecturer of the China Petroleum University, Beijing at Karamay. Welcome to Atral. Nice to see you with us. And he is our also visiting professor of our university. And this topic very interesting for us because we are fully in oil industry, and at the same time this is maybe the technology of the future of this industry. So we would like to talk about non-traditional, non-conventional types of oil refinery. That what now not in the industrial scale use. And so my first question: what is a non-unconventional method of the oil refinery? Can you list them and how they compare with traditional oil refinery?
Okay. Well, thanks for you to invite me here and to be a visiting professor in this conference. It's my great honor to share my opinions about the conventional oil refinery or something some technologies involving this. I think these days most of the refineries are using the traditional method to refine the crude oil. You see, they use evaporation and fractionating tower, the distillation to separate the mixture of crude oil. You see, it is very necessary to separate them because the different engine need different oils, and the different oils should meet the required quality. So the very common way is to use heat to evaporate the fractions. You see,
high temperature.
High temperature as high as 500 degrees Celsius to evaporate the very heavy diesel, and the viscous oil used by the ship.
Sometimes high temperature and vacuum.
Yeah, high temperature to evaporate the fraction. You see, we use natural gas or the heavy oil to heat the fractions. So in some cases, we need the crude oil to crack to a lighter fractions to make the heavy oil to be
cracking also high temperature.
Yes, it's very necessary to use the cracking technology to produce the greener and the lighter oil. So it will cost a lot of energies, a lot of carbon emissions to the atmosphere. But if we want to look at the unconventional heavy oil processing technology, we should focus on the chemical properties of some fractions. You see, if we want to separate the sulfur content from the oil to decrease the sulfur pollution to the air, the traditional way is to use a catalyst to heat the oil to a certain degree and use a pump to let the hydrogen to a very high pressure to break the bond between carbon and sulfur. So if we find a way of a conventional heavy oil processing, we may pay more attention to the sulfur, what chemicals can react with the sulfur atoms in the molecules. So we can use the calcium hydroxide and sodium oxide to absorb the sulfur materials, and we can use sulfur metal, sodium metal to react with the sulfur. We can use oxygen to oxide the sulfur in the molecules, and these reactions can be happened in a very low temperature. So we don't need to heat the oil to pump the hydrogen to a very high pressure. So in the oil refineries, we can find a lot of unconventional oil refining technologies. You can see the electrostatic method, separation method. When this is the first step to process the heavy oil with a content of water. We need to separate the water from the oil, and the oil go to the distillation unit. So we don't use heat to evaporate the water from the oil, the crude oil. We use the
Electricity.
static, yeah. And you see, the water is a polar fraction.
Yeah.
So very, we have oxygen, hydrogen in the different
But
sides.
hydrocarbon non-polar.
Polar. So we use the electric to absorb the water to the electrode side, so we can separate the water from the oil fractions. And another technology emerging in these days, we can see a lot of oil refineries use membrane separation technology to separate the hydrogen from the gas mixture. They use a very large membrane materials. You can get the hydrogen back from the emission, and get the hydrogen back to their units to hydrogenation, to desulfur or something. It's we don't use the pump to cool the gas mixture down. We don't use the energy to let the temperature go down to separate the hydrogen. We use the membrane can let the hydrogen go through the pores of the membrane, and the hydrogen will go to another space. So we collect the hydrogen and get it. You see, a lot of we are concerned about the carbon emissions to the atmosphere. A lot of units, if the natural gas can't be combusted totally, it will emission the carbon monoxide to the atmosphere. Someone are discussing how about use the metal porphyrin to convert the carbon monoxide to the carbon dioxide and absorb the carbon dioxide. So we use this very specific catalyst that catalyst can react at the ambient temperature. You don't need heat. You don't need to let the temperature go high. You can convert the molecules. So it's in this site, in this opinion, this unconventional heavy oil refinery technologies will very attractive, and a lot of researchers want to use the conventional technologies, want to discuss the effects, and to want to develop very new technologies for the refineries, because like our country, the Kazakhstan, and pay much attention, focus on the net zero policy. We want to let the carbon dioxide emission to be to reach a peak, and to make the earth more green, to make the atmosphere cleaner.
What do you think how it's possible to use, for example, for oil fractioning, not thermal distillation methods, but something else, like I don't know, the catalytic or the absorbing methods, or etc.
Yes. We I have give some example about the if we can use the chemical method to replace the conventional technologies. So I think we couldn't change the main technology, the main process for the refineries to turn their method to our unconventional technologies. And in some cases, it's impossible to to use the unconventional method to replace the conventional method. And so I can give an example for this. And if we want to obtain more aromatic materials, more aromatic molecules to produce the rubber, you see the rubber can be used to produce the car tire. Yes, and it's impossible for the unconventional method to change the moleculars of some oil fractions. It's impossible. If you can see, if we want to turn the very long chain of carbon, we need a lot of energy to let them to make a circle. See, we must use heat. We must use a catalyst. We must use them to. I think this kind of energy consumption is necessary for them, and we have another example for this.
But catalyst could reduce this energy.
Yeah, it's like a mountain. The catalyst can open a tunnel for the car to a mountain. You need to go high to the mountain and go down. You just go through the tunnel and you get the product. So I think the catalyst, if you design a very high quality catalyst, it will decrease a lot of energy consumption like this. But I think the chemical method, the unconventional oil refining technology, they can't be replaced by each other. You see, if we want to get the asphalt from the vacuum residue to make the road, it's impossible for the heating method to get the asphalt. We use a solvent de-asphalting unit. It's a very something you don't use heat, don't use much energies to separate. Yes, and if you only use the heating method, it doesn't work. So in this opinion, the conventional method and the unconventional method can be replaced by each other. I think they will exist in the refinery for a very, very long time.
Okay. Anyway, refinery process, the fractioning of oil is anyway this the purpose of this process supposed to be the profitable. So because this is a type of industry, and of course now in conventional processing we spend a lot of energy to separate the oil, the fraction, to purify and clean from anything from sulfur, whatever ions, and so it takes a lot of energy and money. This is on one hand, but how the expensive new technologies can they make this process more profitable?
Yes, I think in some cases it will make some measures very profitable for the refineries. I can give an example for this. There is one kind of oil called FCC slurry oil from the units, and this FCC slurry oil is very heavy, very viscous, but it's a very good materials to produce the needle coke, and the needle coke is it will be used to produce the lithium ion battery for our cell phone, for our machine nowadays. If we want to, but this kind of slurry oil contain many catalyst particles in the liquid, but this before we process the slurry oil to the needle coke, we need to separate the particles from the liquid. If we use the conventional method to separate the slurry oil, we should heat the slurry oil to a certain degree, almost 300 degrees Celsius, to evaporate almost all the fractions from the tank to another tank, and leave the particle deposits on the bottom of the tank. So it's we know that if we want to vaporize some molecules, there is a SMP evaporation SMP. It's inevitable to come over this energy. So in this case, it will cost a lot of energies, a lot of heating. So our group is discussing a new method, a conversion method to separate the particles. We use electrostatic method, and let some particles.
These particles
be
polar.
Powder, yeah.
Is they polar?
Power.
Not powder. They are polar.
Polar.
Yeah. Reacting on electrical charge.
No, it's some particles can be absorbed by the electrode, and these particles driven by the atmosphere, and they will move to one by one slowly to the side, and in the certain of the column we get the liquid, get the cleaner slurry oil that
without particles.
Yes. See, you don't need to evaporate. You don't need to
high temperature.
High temperature to separate this contaminant.
Yeah, very good.
Yes. This is the meaning of how to use the unconventional method to save our energy, to decrease the carbon dioxide emission.
Another critics, especially for example for our refinery plant, that you are not sustainable. You have a lot of emissions, everything. So how unconventional method could make this processing in oil refinery more sustainable?
You see, I think it is hard. It is difficult to let the administrator in the refinery to accept our new method, to accept our unconventional oil method, because I think it's a very universal way of one new thing developing. You see, I have ever seen the museum in our campus that in the beginning we use a big tank to evaporate the crude oil and get the lighter fraction for the car engine, and later fractionating towers come out. We use this column, this tower, to get our gasoline, to get the diesel fuels. Nowadays, the fractionating tower with a capacity of 10 million tons per year, with a capacity of very large scales emergency can come out. So I think it will take about 60 years or more to develop to a very effective model. So if we want to put the unconventional method to the oil refinery to decrease the carbon dioxide, we should pay much. It's a long way. It's a long way for us to get the experimental data, to design the equipment, to discuss if it is safe, if it is profitable for the refinery. You see, if we want to decrease the emission, and the inevitable thing is that we should cost a lot of money. cost a lot of money to redesign the equipment, to optimize the process method. So it's a normal thing for us. Yes, you should know that it's a long way to go. It's a long way to go. You just keep going, never give up. And the one thing you should do is to make your new technology sustainable, effective, profitable, reliable. Sustainable, yes. And I think in the future it will.
But there is already the small scale solutions, yeah?
Yeah, some pilot plant and to handle the very, very, very heavy materials to decrease the contaminants from the product.
Do you believe in the future of this non-thermal conventional methods?
Yes, I believe, but I should, but I also have an opinion that it's impossible for us to change the main routine, the main method of oil refinery, but we can focus on the product quality, the contaminants in the products, and their pollution effects to our atmosphere. If the refinery require the higher quality to let the diesel, the gasoline to a cleaner quality, that's what we can do for them. We can use the chemical method and conventional method to separate the contaminant from the effects. This is our opportunity to develop our own technology. So I think in the future, I think the membrane separation is a very attractive technology. You see a lot of countries focus on the net zero policy. They can use the membrane separation method to separate the carbon dioxide from their gas, the gas mixture, and
wasting gases. Yeah.
Yes, I think a lot of researchers design the catalyst to let the tunnel on the mountain lower and lower. You don't need to go to a very high the energy peak to reach your purpose. I think in the future, some more and more new technologies, more and more unconventional oil refinery technology will combine with the conventional method, and they will combine together, work together, and make our carbon emission, our environment more green, more friendly.
Do you know now some cases of large scale the production using the non-conventional, or it's under investigation?
I think it's a long way. It's a long way. Yes, there are.
But you're optimistic. Yeah.
Yeah.
Okay. Yeah, I know, because now people more sensitive to ecology, to the sustainability. For example, in Atral refinery plant that was built 80 years ago here. When it was built 80 years ago, it was outside the city. But city, the growing, so now the plant inside the city. And a lot of people critical about this plant and the emission to atmosphere. So the people inside, they are not satisfied that the plant now located in the city. And more people understand that the health more important than any sort of the oil products. So I believe your unconventional method has a future.
Yeah. I think I'm very confident to see that we have a lot of new technologies to separate the poison materials, to stop the pollution about the pollution from the plant. If we do necessary change, necessary optimization to the plant, to the unit, the pollution could be 90%, 99% of pollution can be controlled in their plant, and the plant oil refinery can surely convert the pollution to very useful materials. Yeah, for us, I think so. Just say we don't scared of the plant. We have a lot of technology, a lot of new method to handle the pollution, to protect our healthy. Yeah.
Okay.
Yeah.
Thank you very much, Fan, for your coming.
Thank
Yeah.
you. Thank you. Thank you.
Enjoy your staying with us. Another welcome.
Okay. Thank you. Thank you.
Yeah.
Thank you, sir.
Құрметті көрермендер, келесі апта кездесеміз.